The reference angle approach. The reference angle approach is used to determine the values when given an angle that is not in the first quadrant. Let's consider an angle in the second quadrant of 135 degrees. The reference angle lies in between the terminal arm and the negative x-axis. We will call this angle theta. How do we determine the value of theta? Well, we know that from the positive to the negative x-axis, we have 180 degrees. And so, naturally, theta is equal to 180 degrees minus 135 degrees, which is 45 degrees. And now we have our reference angle. We will now determine the values of sine 45 and cos 45. As we know from our unit circle, sine 45 degrees is root 2 over 2, and cos of 45 degrees is also root 2 over 2. Recall the cast rule. We see that the terminal arm lies in the second quadrant, where sine is positive and cos is negative. And so now we know the signs of these values of sine 135 degrees and cos 135 degrees, which are root 2 over 2 and negative root 2 over 2, respectively. Let's consider a different example, with the terminal arm lying in a different quadrant. Here we have 240 degrees. And we see that the reference angle lies in between the negative axis and the terminal arm. We will call this alpha. Once again, we have 180 degrees, and so naturally, alpha is equal to 240 degrees minus 180 degrees to give us 60 degrees. Sine of 60 degrees is equal to root 3 over 2, and cos of 60 degrees is equal to 1 over 2. We're going to recall the cast rule again to determine whether our ratios are going to be positive or negative. We see that in the third quadrant, both sine and cosine are negative. And so we have sine 240 degrees is equal to negative root 3 over 2, and cos of 240 degrees is equal to negative 1 over 2. What if we aren't given the angle, and we have to determine it using the ratios that we are given? If we are given that sine theta is equal to negative 1 over 2, and cos theta is equal to root 3 over 2, what is our angle? Well, recall the cast rule. We see that sine is negative, and it is negative in the third and fourth quadrants. But we have a positive cosine ratio, which means that our terminal arm has to lie in the fourth quadrant. We have been given these ratios that are from our special triangles, and so we have three options that our reference angle is either 30 degrees, 45 degrees, or 60 degrees. If our angle is 45 degrees, we see that both ratios are of nature root 2 over 2, and we just saw with our last example that sine of 60 degrees is equal to root 3 over 2. And so the only special angle that is left is 30 degrees, or pi over 6. And so our reference angle is 30 degrees, and it lies between the x-axis and the terminal arm. So now we have theta. To determine what theta is, we see that we have 360 degrees going all the way around all four quadrants, and so theta is equal to 360 degrees minus 30 degrees, which gives us that theta is 330 degrees. One very important rule to remember is that the reference angle is only in reference to the x-axis. We cannot have it stemming going from the y-axis or a different terminal arm. It is always stemming from the x-axis. And so we have four little rules to remember when trying to determine what our angle is. So if we have that our terminal arm lies in quadrant 1, then theta is equal to the reference angle. If it's in quadrant 2, theta is equal to 180 degrees minus the reference angle. If it's in quadrant 3, theta is equal to 180 degrees plus the reference angle. And if it's in quadrant 4, theta is equal to 360 degrees minus the reference angle.